All right, so again, just back up here at 312, basic output programming. You guys should be here following along. This link is to the vrvex.com. There's some resources that we're going to get into later, but right now we're looking at the monitor button at the top right of our screen. It looks like a fan or a sunrise or something like that right here. It'll pop up and we'll see some text here, which will make this text now. The hello world text. It's right here in natural language. Line 4 gives us a little bit of what some of the pseudocode abbreviated commands will look like. And then actually you can unhide this. You can say check your response and see an actual example of pseudocode. Hopefully you create this before. That's the intention, but it's okay to look at it. So we're going to create our program based on the pseudocode. Select the playground grid map. Playground shown in the drop down list. Click the play button to test your program. Observe that the printed output appear in the lower section of the monitor panel. Okay, let's take a look. So here's the pseudocode that I'll use. I'll go to the Vex VR thing, and I'll say, okay, it wants me to use the looks button here. So going back, kind of in between this is what's nice about having two monitors. Set color, print red, print hello. Next line, set color, print blue, print world. Okay, print world. All right. So I go, all right, let me set the color, set my print color. This is the purple output text. I'll set it to blue. I'll print the text. What text? I'll print hello. Hello. And then I will go, yeah, next line. Where's the next line button? Let me scroll in a little bit here. On next line, it says, oh, set cursor to next row. Okay, that must be it. Change the color to blue. No, not blue, to red now. And then print the word world. Yeah, feels good. Now, over here, this is where this text would show up if I actually played this thing. But how do you do it? Well, I could play it right here, but it also says, I don't know why it really says this, to be honest with you. It says to open up the playground and change it to grid map here. I think it's because you have a control panel down here too. But I think this will work if I push it up here. Yeah. So it said hello world, right? Right here in this monitor. Do you guys see that? Hello world. I made it print out this text over here. Nice. Cool. Now it seems kind of basic and lame right now because you're like, wait, you just typed hello world and then you started the program and it typed hello world. So what advantage? Well, you can make it type things or say things based on what's happening with the robot. So you can mix between print text and actual physical what the robot does. So for example, where can you think of something like? Can anyone think of a situation where a robot's moving around and it prints out something for the user or somebody that is controlling the robot? Like, what would be useful? Food delivery robot. What's up? Yeah, you could say that would be a great one. A food delivery robot that sends a message to the person like, oh, maybe it's just a funny like, oh, enjoy your meal, or maybe it's an actual like, oh, don't forget to blah blah blah, like with this meal, be careful, it's hot, or I don't know, something of that nature. But yeah, after something happens, you can print the text out to a user or end user. Would be good. That's not a bad example. Okay. All right, so we'll move on. If that's what hello world is right there, that's the basic like print that you did. It said, hey, there's some mistakes there. You can look at it. Well, what do I need to do? It's just kind of, you guys are used to it. Control Z, backspace, all this stuff. If you undo too many times, you can redo with Shift Control Z. Okay. This is the first section. Now, this is where screenshots, this is how you turn this stuff in. They give you a text that you are going to do. You have to write this text, basically. You're going to print out this text, just like we did Hello World. There's 3 different colors. They're spaced in different lines. There's a little thing on there. This is number 1. There's 3 sections kind of to do. This is planning an algorithm. It's not really, this is an actual thing to do. It's pretty much like first step, second step. But it's actually what the objective is to create this text in the monitor like we just did. It does say in your notebook, create pseudocode for your program. So again, it would look like this, but it would just be right here. It'd be creating this text here. That's what pseudocode would look like. And then it says after you complete your pseudocode, write your program. Before you run your program, you need to click the clear button in the lower section of the monitor to remove the previous printed text. In addition to the play and reset buttons in the playground view, start and stop buttons are above the monitor button. Use these to run your program as well. Okay, this is great. So it says playground window. Each time you run the program, the playground view opens. You can close it or something like that if you want to. All right. It says test and debug your program until it matches this figure right here, figure 2. So I want you to do all that. You can get the output repeatedly by only clicking stop and start without using the clear button. This may require a new button that you did not do not pseudocode. So what it says here, this line number 8, it says basically, can you get it to just do it every time I start and stop the program? Do the text again. Not necessarily like that text is like 100 times on the thing, but can you have it clear? There, if you click on the hint button, there's a clear all rows. So you could put that, and where would you put that? You'd actually probably put that at the front. You might think you put that at the end, but no, you'd put that at the front of your program, because if you put it at the end, it would create the text and clear it before you even saw it. But if you put it at the beginning, it clears whatever's there, and then it creates text. So if I use that example in the hello world, if I say, yeah, clear all rows at the beginning of my line, and then I run this program again, it would clear. Okay, stop. Okay, run it. Stop. It doesn't look like anything's happening, which is good because it's actually good that that's happening because I just want to have hello world. If I don't have that clear there, let me go rid of that again. And I run my program, what's happening? It's not clearing the old text. Talks about a clear button down there, but again, you can put that in your coding right here, save you time and only have to click it a couple times. So you do use that clear all row at the beginning of your program. When you're done testing, download your program and outputs shown in the monitor panel. Name and share your file as directed by your teacher. So that's basically, okay, once you have your code, it does say something about save to your device. You can actually just go up here when you're like this. You click share right here, and it shares the actual code, which is fine. Or you could just do a screenshot. I'm not sure how many of you are familiar with the snipping tool, but I love the snipping tool. If I say play this program right here, it says hello world, I can actually take this thing called the snipping tool on these computers. Do you guys know what that is? So down at the Windows button, if I start typing snipping, I click on the Windows button and start typing SNIPP, or snipping tool with like a scissors comes up. It looks kind of like this. If I click on it, this screen right here comes up, and I can go, hey, I want to do a new snipping tool. And everything kind of turns gray, and then I can just take this and like drag over here, and then I get I get an image of all of it. Even me, I'm on the screen. Whatever's on the screen. Okay? Love it. Love the snipping tool. And kind of customize what I want to screenshot. So that's something you can turn in as well, as long as you get the. What I like about that is also gets the text in there and the code in one shot, which is nice. You can file and save to your device, but again, it looks, when I open it up, I can't really see the file type very well. So I don't love it. Okay. All right, now let's move on. This was the first section. Again, you're creating that suit. You're creating that code. You can rename it. That's what that says right there. Basically, I can go in here and say, oh, it's not gold one. It's gold one rather, not gold three. And I'm doing 312. PLTW. Okay. Yeah. All right. I can save it and I would have that name. All right. The next one is snail driving. Snail driving. In addition to pseudocode, programmers use flowcharts to help them conceptualize their program. This is part two. Part one is just the creating the pseudocode, or not creating this code right here using this example. You basically have it print out that code. Some of you might be done already with it. Nice. You are? Good. This one right here is snail driving. It talks about flowcharts, and it has these things that we'll cover. You would actually go through this. You'd look at the different things to create a flowchart. So let me go through this at the end. I'll just go to the end. Now, the shapes of the blocks do matter. There's a start, input, an output. So right here, step 6. Make sure. This is the last one. So basically, this is a flowchart that has a program for algorithm up here. It's a start. There's an input. It says a number. You do something. Something happens. You add something, and then you ask the computer to analyze what it is, and you make a decision off of that. And it's either no or yes based on whatever your standard is. And so this is, hey, is the number greater than 9? If it isn't, then go back and wait for the next until it is, basically. So it does give a knowledge check for flowcharts. Try that after looking at these steps here. This is the what you want to do for this one. You actually draw a square. It's having you draw a green square. So the snail bot or the snail racer, whatever it's called, this one here. Oh, where is it? Snail driving. You're drawing a square with your robot. Okay. You use the pen to do that. Change the color of the pen. You can do that. Once you have your code, take a screenshot of it and or save it, and then that's what you also add to Canvas. Okay, for 312. The last one, GPS ping. You're pinging your position. So when programming with inputs such as sensors, it sometimes helps to know exactly what is happening with the inputs as the program progresses. In VexCode VR, you can get a sensor's value to help you track why some programs behave the way they do. For example, you can get a robot's exact XY location in the grid. Nice. So it talks about your engineering notebook. Write a flowchart to move the robot square by square to all 4 corners of the grid map, reporting its XY position in each corner. You can use an abbreviation, move VRSDV, and squares to move more than one square in the same direction. Add a print block to output the position in millimeters. The position block is found in the sensor section. You need both X and Y positions to report the coordinates of the grid. Ah, cool. Add helpful output to identify all 4 corners using messages such as top left corner, blah, blah, blah. Document the X and Y location of the 4 corners of the grid map. Download and share your program. That's the last one. There's 3 of them. One is creating that little printout algorithm. 2 is snail driving, making a square. And 3 is taking your robot to all 4 corners and having print out the location of those corners. Got it? All right.